Topic 7-2, Growth and Decay. This can be referenced with our Holt textbook, Chapter 11, Section 3, starting on page 781. Okay, we're going to look at some practical applications of using this formula for the exponential growth and the formula for exponential decay. So if you're looking at the A equals, C being your initial amount, you're going to take the R rate and add 1 for growth. So just think of growth as adding something to it, whereas decay would be subtracting. Okay, you're going to raise this. It's written as a percent. So if this is written as a percent, this is the percentage of the rate, so you want to change it to decimal form. T is the time, so you'll raise it to that power, and A is your final amount. This will make more sense when we do a few problems. But for decay, you're looking at the same formula, and yet you're starting with your initial amount. This is the rate of decrease, so you're subtracting it from 1. If it's written as a percent, change it to a decimal, raise it to the power, the rate raised to the power of whatever time that's asked, and then you will have your final amount. So let's look at this first one. A population of Johnson City has grown at a rate of 3.2% per year for the last 10 years. If this population 10 years ago was 25,000, what would be the population today? So we're thinking about it being just 10 years ago. So your initial amount is 25,000 people. That would be a growth rate, so we're going to add it to the percentage, but 0.032 is changing that to a decimal, and you're raising it to the power of 10. So be careful when you're changing percents to a decimal, you move it 2 places. That's why you're going to have a placeholder right here. Now the percent sign goes away. So putting that in your calculator, 25,000 parentheses 1 plus 0.032, close the parentheses, use your house top right here, raise it to, whoops, I needed a 2 of them, raise it to the power of 10. And you should get that they will increase their population to 34,256 people roughly. It's an estimation. This one you wouldn't round just to a whole number person. Okay, let's look at next one. There's only 2 examples from Growth and Decay, and then 3 and 4 are review questions. A tractor has a depreciation rate of 19%. 19% written as a decimal, you're going to move this twice, will be 0.19. If the original price of the tractor was, so that's your C, your original amount, and the value of the tractor after 5 years. Depreciation means a decay, so it's subtraction. So you've got the 1 minus the 0.19 this time. Raise that to a power of 5 years later. So when you talk about something depreciating, the value of it will go down. So in 5 years, if it depreciates at 19%, if you put this in your calculator, you're going to get that that tractor is now only worth $10,111.64. Quite a huge change in the original price you paid for it and the price the value of it will be after 5 years. So very practical application about depreciation of vehicles and things like that. You can use this formula. Okay, this is a review from previous units. When you factor a polynomial where you have a common x in every term, you're wanting to look to see if there's something you can divide by each of your whole numbers. So I do know that 3 will go into each of these numbers, and then the value of my x's, since I have 4 x's, 3 x's, and 2 x's. If you want to mark that, you have 4, you have 3, and you have 2. So how many common ones do we have? powers of just 2 of my x's. Every one of these can be subtracted out when you do the division of the same base. When you have the same base, you can have a common variable will always take the one with the lowest power. So after you do this division, you use the 3x to the 2 as the part that stays on the outside. To factor completely, we have to do the division. 6 divided by 3 is 2. 4 minus 2 is 2. So you have 2 x's left over. This would be a negative 7 and just an x. And notice what happens here. All of those go completely away, and this would just end up being minus 4. Okay, you want to see if this factors more completely. I didn't double check to see if that did. We'll do that in a minute. Let's just leave that one like that. Let's do number 4. Find the equation of a line parallel. So if we know that it's parallel, write the word here, same slope. If it's a parallel line, it's going to have the same slope as this equation. Although we don't know the slope, this is written in what's called standard form of an equation. So what you want to do first is rearrange this. So to rearrange this, you're going to have 5y equal to a negative 2x plus 15. You're trying to put this into y-intercept form. So if you need to write your y-intercept form of an equation, put it up there. That's the formula that you were changing this to. So if we want y equals, we still have a 5, we want to divide by 5. I moved the 2 across the equal sign by combining opposites, and then I divided by 5. So y is equal to a negative 2/5 x, we're just cleaning this up a little bit, plus 3. Not necessarily needing the 3, I'm looking at having the exact same slope and passing through this point. So if it has the same slope, you're going to use, this is a lot of review of algebra, you're using the same slope. You're going to have your slope here, and you're using the point slope form of an equation to solve for this. What you're doing is you're putting in numbers. Y minus the y, which is 3, I'm using the point from the problem, equal to the negative 2/5, because I have the same slope, as x minus a negative 5. I got this point and this point from here using this formula. All I'm doing is plugging in values. With distribution, this becomes negative 2/5 x. Be real careful because this ends up being a plus. Minus a negative is plus a positive, so that changes to a plus sign. Don't forget that or you'll end up with the wrong equation. So this becomes, you've got over here negative 2 times a positive 5 is 10. Negative 10 divided by 5 is just a negative 2. So negative 2/5 times 5. Notice how those go away and you end up with just negative 2. That's where I got that. Okay, y minus 3. Not quite finished. You got one more thing to do. You got to add 3 to both sides. So now our final equation is, because this goes away, is y equals, we have the same slope, negative 2/5 x, and a negative 2 and a positive 3 would give you a positive 1. And if this factors, go ahead and do that, but we're going to stop right here.